here we have our circle with all of our special angles that we talked about, 30 degrees, 45, 60, 90, and then the family of reference angle values given all the way around. So we're given all the degree measures that we have seen in the past and their radian measure equivalencies. So let's go back to that quick way that we talked about for converting from radians to degrees. So if you see pi over 6, pi is the same thing as 180. 180 divided by 6 is 30 degrees. Pi divided by 4. 180 divided by 4 would give you 45 degrees. And then 60 degrees would be pi over 3, and I could do that conversion very easily. 180 divided by 3, and that gives us 60 degrees. Here we have pi over 2, and that's the same thing as 90 degrees. So 180 divided by 2, and that gives us 90 degrees. As we go around our circle here, we're going to start to pick up the family of reference angles as we go through the rest of the quadrants. So here, this is our 60 degree reference angle family. And how would I know that this would represent 120? So we have 2 pi divided by 3. Now, a few minutes ago we talked about how we can actually separate this as 2 times pi divided by 3. And that's helpful because pi divided by 3 we know is 60 degrees. And 2 times 60 gets us to 120 degrees. So for our 45 degree family, here we have 3 pi divided by 4. Pi over 4 is the same thing as 45 degrees, and 3 times 45 is 135. 5 pi over 6, that would be 5 times pi over 6. Pi over 6 is 30 degrees, so that's 5 times 30 degrees, which gives us 150. Now, one thing that we will notice is that it's really easy to work with the reference angle families when we are written in radians. If it has a pi over 6 in it, that represents our reference angle of 30 degrees. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All the pi over 6's basically are called the pi over 6 family, the reference angle family, and that's the same thing as 30 degrees. So pi over 6 we said was 30 degrees. This would be 150 degrees. That would be 7 times 30, so that would be 210 degrees. And then 11 times 30 degrees would be 330 degrees. So we're still working with that 30 degree reference angle family, but when we talk about radians, it's now called the pi over 6 reference angle family. And we have the same thing when it comes to 45 degree angles. So our reference angles for 45 degrees. Now we're going to call that, instead of the 45 degree angle family, the pi over 4 family. So the reference angle family for pi over 4, really easy to recognize because they all have pi over 4 in them. 45 degrees, 135 degrees. 5 times 45, we end up with 225. And then 7 times 45, we end up with 315. So a lot easier actually to recognize our reference angles in terms of radians. That's our pi over 4 family, and they all have pi over 4 in them. And 60 degrees, same thing. Pi over 3 is 60 degrees. 2 times 60 is 120. 4 times 60 would be 240. 5 times 60 would be 300 degrees. So our 60 degree reference angle family in terms of radians now would be called the pi over 3 reference angle family. For this example, we are asked to find tangent of 2 pi divided by 3. So tangent of 2 pi over 3, if we do our conversion, a quick conversion, what we're really looking for then is 2 times, we can think about that as pi over 3, that's 2 times 60. So what we're really looking for is tangent of 120 degrees. Now, if we think about pi over 3 as being equivalent to 60 degrees here, then what we're actually doing is we're putting our angle in standard position and we're measuring off two segments of 60 degrees. So here's 60 degrees, that's pi divided by 3. We want two of these. So when I go two segments of 60 degrees, so here's another 60 degree segment, that would be 2 pi over 3's. So 2 pi over 3 radians can be found and graphed very easily by going two 60 degree segments or two segments of pi over 3. And that's the same thing, of course, as 120 degrees. So we are in quadrant 2. Our reference angle, just by looking at it, we can tell that our reference angle is 2 pi, or our reference angle is pi over 3. Pi over 3. And 120 degrees, we also know, has a reference angle of 60 degrees. So if my reference angle is 60 degrees, and I'm in quadrant 2, then we know the sine and we know the number for tangent of 2 pi over 3. So the sine, well, we're in quadrant 2, tangent is negative, and the tangent value of 60 degrees, or pi over 3, is the square root of 3. So our answer would be negative square root of 3. In example B, we're asked to find secant of 7 pi over 4. So we want to measure off what our angle is, and that would be 7 times pi over 4. Pi over 4 is 45 degrees. So 7 times 45 degrees, that would be 315 degrees. Basically what we're saying is we are measuring off 7 segments of 45 degrees. So here would be 45 degrees, so we go one of those, and then second one of those will put us at 90 degrees. So here's another 45 degree segment. And another 45 degree segment. So there's 3. Here's 4 45 degree segments. Go another one. Here's 5 45 degree segments. And then 6. And then here is 7 45 degree segments. Another way that we can think about this is in terms of radians. We could say that this is 1 pi over 4, 2 pi over 4s, 3 pi over 4s, 4 pi over 4s, 5 pi over 4s, 6 pi over 4s, and then here we hit 7 pi over 4s. There's a couple of different ways that we can count all the way around. But that's the same thing as 315 degrees. Now the quadrant that we're in is quadrant 4. Our reference angle is pi over 4, or 45 degrees. So if our reference angle is 45 degrees, secant of 45 degrees, let's pull that back up here, secant of 45 degrees would be square root of 2. So we have square root of 2, and since we're in quadrant 4, secant is positive. So our answer for secant of 7 pi over 4 would be positive square root of 2. So we find the quadrant that the angle is located in, and then we find the reference angle, and then we know the number and also the sign of our secant value. Now we are asked to find sine of negative 7 pi divided by 6. And just by looking at it this time, we should know that our reference angle is the pi over 6. That's that multiple of 7. So 7 pi over 6. We can tell because we have that pi over 6 that the reference angle would be pi over 6. And that's the same thing as 30 degrees. So a reference angle would be 30 degrees. What's the sine value at 30 degrees? Well, that would be 1/2. Now we don't know if we have a positive or negative, and that depends upon what quadrant that we're located in. So let's look at negative 7 pi over 6, and let's see what quadrant that we're in. Now pi over 6, we're going to put our angle in standard position, We're going to go pi over 6 or 30-degree segments, and I need to go 7 of those in the clockwise direction. So here is a segment of 30 degrees. So there's one of those. Here's another segment of 30 degrees. There's 2 of those. 3 of those. 4, 5, 6, and 7. So 7 segments of 30 degrees going in this direction. That would be the same thing as going in the direction, let's say 30 degrees is pi over 6, so that would be minus pi over 6, minus 1 pi over 6, minus 2 pi over 6, minus 3 pi over 6, minus 4 pi over 6, minus 5 pi over 6, minus 6 pi over 6, minus 7 pi over 6s. So we can tell that we are located here in quadrant 2. What will be the degree measure equivalent to this? Well, pi over 6 we said was 30 degrees. So 7 pi over 6, negative 7 pi over 6 is equivalent to negative 210 degrees. And that all adds up and is consistent with what we know about negative 210 degrees. So is sine positive or negative in quadrant 2? The answer is positive. So the sine of negative 7 pi over 6 would be positive 1/2. Now we want to find cosine of 3 pi. So let's measure off and figure out where 3 pi is located. So remember that pi itself is a half rotation. So if I go all the way around 1 unit of pi, that is half a rotation. So there's 1 pi. 2 pi would be going all the way around the circle completely. So we have a full rotation. This says we have 3 pi's. So 1 pi, 2 pi, and then we keep going, another half rotation, and we hit 3 pi. So 3 pi is right here. Now we don't have a reference angle because it actually lays on the axis. So what was the point that we used before? Well, we used negative 1 comma 0. We use a point on the terminal side of what we call the quadrantal angle. So cosine, we're going to define that as we said x over r. So that would be negative 1 divided by r, which we said was 1. So negative 1 divided by 1 would be negative 1. So cosine of 3 pi is a quadrantal angle. We use the point that lays on the terminal side. We know our x, we know our y, and we know the r. X over r, we get our cosine value of 3 pi. We can also convert from radians to degrees here. So 3 times pi, of course that would be 3 times 180 degrees. And that would be equal to 540 degrees. So we can always convert to degrees and then find our angle, graph our angle, and then find the point on the terminal side and find cosine from that. Sine of negative 14 pi divided by 3. So we can convert to degrees if we want to. So that would be negative 14 times pi over 3. Pi over 3 would be 180 divided by 3, so that would be 60 degrees. And 14 times 60 degrees, that would give us 840 degrees, negative 840 degrees. So we can measure off that angle by working in terms of degrees, or we could also count off 14 segments of 60. So let's practice with that idea. We're going in the counterclockwise direction, or sorry, the clockwise direction because we're negative. So we're going to start here at our initial side, and here is a 60-degree segment. So that's one of those. And here's 2 60-degree segments. And here's a third. And here would be a fourth. And a fifth, and here would be a sixth. So we go 1 of those, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So if I go 14 segments in that clockwise direction, this is where I would end up stopping. So we go 14 of those. Remember, that's the same thing as saying 14 pi over 3's. So all of these are pi over 3 segments. So this would be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, and so on. So we're right here in quadrant 3, and the reference angle, of course, is pi over 3. We could tell that just by looking, or 60 degrees. So what is the sine of 60 degrees? Well, that would be square root of 3 divided by 2, and sine is negative in quadrant 3. So sine of negative 14 pi divided by 3 will be negative square root of 3 divided by 2.